Hello again. This is lesson 48, Algebra 1. We're going to talk about polynomials, their degrees, and the addition of polynomials. So in the past, this is what we've been working with. Look at all the different examples, A and B and C, D, E, F, G, H, and I. And all of these are simply expressions. They're called algebraic expressions or mathematical expressions. Okay? And are individual terms or indicated sums of terms. All right. A through D, because they're complicated algebraic expressions, they don't have a name, a special name, so we just call them a term or an algebraic expression. But the simple ones that are shown in E through I have a special name called polynomials. You'd be familiar with them, polynomials. And we wonder, why on a simple term are we giving such a complicated name? It's just what it is. These don't have a name. They're complicated. They're just called algebraic expressions or terms. And these, E through I, are called polynomials. What does that mean? So polynomial takes the form of a times x to the n. All right? Where a is a real number and n is a whole number. So for instance, 4x squared, negative x to the cube, negative 1.44 x to the 32nd. We said n has to be a whole number, so it couldn't be to the negative power. 2x to the fourth, negative 7x, and simply negative 7. Why is that a polynomial? We said a polynomial must be this, where a is equal to a real number and n is a whole number. Okay, we remember what whole numbers and real numbers are. So, but there's no variable. But guess what? Isn't it implied x to the 0 power? Isn't x to the 0 power 1? 1 times negative 7 is negative 7. Therefore, negative 7 is considered a polynomial. We're like, so we don't think of it as looking like this, but it does because it's an implied times 1. What's another form of 1? X to the 0 power. And isn't 0 a whole number? Okay, so to be a polynomial, it must meet the requirements. If you look on page 193, it says each algebraic expression is in this form a times x to the n. Yes, it does. Every one of these do. The numerical coefficient of each algebraic expression a is a real number. So this is the coefficient, right? This is an implied negative 1. Here's your coefficient. Here's your coefficient is negative 7, right? And here it's 2. Remember, the coefficient is your number, your constant. So if it doesn't have one, and it just has a variable, it's an implied 1. So they all have coefficients, and the exponent of the variable n must be a positive integer, or it is the number 0. So it basically has to be a whole number. So I couldn't have 2x to the negative squared. That's no longer a polynomial. It does have a coefficient of a real number. It is in the form a to the x to the n, but guess what? My exponent n is not a whole number, and it's negative. So therefore, it does not, that is not a polynomial. It must be all three of them, okay? So let's refresh our memory. Anything to the 0 power is equal to what? 1. All right, so a polynomial of one term is called a monomial. So these are this one, this one, this one, this one, this one, this one. These are all called monomials. That's just how we classify that, and it's polynomial. But monomial, mono means one. There's one term. Okay? If you have two terms, so if I have 4 plus x, remember what is a term? It's separated by a plus or minus. I've got two terms. Are they both polynomials? Yes, they are. So they're called a binomial. Then if you have 3x plus y plus 4, I've got 3 terms, and it's called a trinomial. They're still polynomials, so we classify them by how many terms. Okay, so the definition of a polynomial is one unknown, that's the x, in an algebraic expression in the form of 4x 15 plus 2x to the 14 minus 3x to the 10 plus blah 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 plus 2x plus 2, where the coefficients are real number and x is a variable and the exponents are whole numbers. Okay, so it's one unknown. And if you look at that whole thing, it's written at the bottom of page 193. I'm going to write that on the board. Okay, saying that, turn to your page. And it says, so we already said that if it has a negative power, it is not a polynomial. So if I have 4x to the negative 3, not a polynomial because my exponent is negative. Okay, negative 6x plus y over z, that's not a polynomial, right? Because z has to be in the, if we move z up, we now get z to the negative 1 power. And it's no longer, it's not a polynomial. Okay? And because it's not in this, in here, it's not in this form. If we put it in that form, then z becomes the negative 1, and then we no longer, again, it's still, n is not positive, not a whole number. Okay? So let's look at the following. Let's see. A polynomial, one or more unknown, is an algebraic expression having only terms of the form a x to the n, y to the m, z to the p. So a x to the n, y to the m, z to the p, dot, dot, dot. Those are also polynomials with more than one unknown. Your unknowns are x, y, z. A is still your coefficient. Okay, so x, y, z squared to the m times m is a polynomial. Okay, it can take on this form as well with more than one unknown. But you still have to have your a, it's an implied 1 there, right? And then all the exponents still have to be positive, all the n's. So it is still a polynomial of more than one unknown. The next thing we're learning is about the degree. It's another way of classifying polynomials of a polynomial. And it's the sum of the exponents of the variables in the term. So let's look at 4x cubed. Okay. Let's look at 6xym. And let's look at 2x squared y. Okay, degree is you take all the powers and you add them. So this is to the power of 1, right? Any constant or coefficient, their degree is considered 0. The variables, you look at their power. So you have 1, 1, 1. You add them all together. So this has a degree of 3. Here you've got 0 and 3 has a degree of 3. Here you have 0 plus 2 plus 1. So these are all polynomials in the degree of 3. So the degree of a polynomial is the same as the degree of the highest degree in term. So let's look at a trinomial. 3x squared plus xyz plus m. So we said this is a trinomial because it's got three monomials, or three polynomials added together. So there's 3 of them, so it's a trinomial. Then we want to see what each term, the degree of each term. This one's going to have a degree of 2, with exponent of 2, and any constant to the 0 power, so 2 plus 0 is 2. This one has 1 plus 1 plus 1 has a degree of 3. This one has a degree of 1 because it's implied to the 1 power as well. So what's the highest number of this trinomial? Degree of which term has the highest degree? The second term. The degree is 3. So this whole trinomial, the degree is 3. So you would classify each polynomial, whether it's a binomial, trinomial, monomial, by its highest degree of each term. Okay, so you're like, I'm a little confused. Well, let's look at another one. Let's look at 4x to the 5th plus yx cubed plus 2x squared plus 2. Okay, this is a constant, this term, so all constants have a degree of 0. This one is a constant, so 2 has a degree of 0, and then x has, on the variables you look at their power, plus 2. So this term has a degree of 2. This one has a 1 plus 3, so it's a degree of 4. And this one is 0 plus 5, or 5. So on this polynomial, it's got 4 terms. And we don't have a name for those. Say 4-term polynomial. Which term has the highest degree? This one. And what is that degree? 5. So this entire polynomial has a degree of 5. Okay. So let's look at another one. And so that's all. It's simple as that. It's not complicated. Don't make it complicated. You're just looking at the power. So we have negative 2x to the 5th plus x cubed y squared, or m squared, sorry, plus x to the 4th m minus 6. Okay, this one has a degree of what? 5 plus 1 plus 0 plus 6. This one has 3 plus 2 is 5. 4 plus 1 is 5. Constant has a degree of 0. So what's the highest degree? 6. So this polynomial has a degree of 6. That's all it is. Now, since polynomials are composed of individual terms, right? 4 terms there. The rule for adding polynomials is the same rule that we use for adding terms. Like terms must be added. Right? So they want us to add these 2 polynomials together. And they want us to put them in order in descending order of the variable. So let's do x cubed plus 3x squared plus 2. And they want us to add it to 2x cubed plus 4. If we had a negative, we'd have to distribute this negative all the way through first before we could combine in like terms. But we don't, so we can just look at the like terms. I don't have anything to add to this here. So x cubed, these are like terms, so positive 3 and positive 5 is plus 5x squared. 2 plus 4 is 6. Are they in descending order? Yes, they are. X cubed, x squared, and no variable. Another way to do is look at the degree. What degree is this? 3, 2, 0, and they're in descending order by the degree. Makes it much easier. Okay? So let's look at the next one. Here they're going to throw in a negative for us. So we have to look at it as the distribution property. 3x to the 4th minus 2x plus 3 minus x to the 4th minus 2x cubed plus x squared. So I can get rid of this parentheses. To get rid of that, to imply negative 1, because of parentheses, it means I must distribute that negative 1. Just as if I would have had a minus 2. I'd have to take that negative 2 times every term, so the implied 1 is no different. Negative 1 times positive x to the 4th is minus x to the 4th. Negative times a negative is a plus 2x. Negative times a positive is a negative x squared. And so now we can simply, simply add like terms. So these two are the same, x to the 4th. So 3 minus implied 1 is 2x to the 4th. Then I have an x squared all by itself. Then I have the 2x's, negative 2x plus 2x equals 0x, and 0, I mean 0 times x, which is 0, so we can drop that, cancels. And then we have plus 3. And that's simply your answer. Oh, I'm sorry. This is a cube, so they don't cancel out because they're not like terms. So it's plus 2x cubed minus 2, minus x squared minus 2x plus 3. Let's see, 4, 3 squared. 4. Oh, this is a square. Sorry. Which would make these two together equal negative 3x squared plus 3. There we go. There's your answer. And that's all you do. You just, if you have a negative here, it's an implied negative 1. It's not any different than negative 4. You must distribute that, and you can get rid of parentheses, and then you simply combine like terms. And they want them in order by the descending order of their power of the variable. Or you could say the descending order of their power of the degree. Degree of 4, 3, 2, and 0. Now, are they in descending order? Yes, they are. And that's the proper way of writing them in order. So, it's important that you remember to change the sign here. So once you do the practice problems, again, there is no code on this homework. All right?